Welcome to this class. This session, we are going to do some examples on how to find derivatives using chain rule. So I have 6 problems, A to F. Okay, so let's discuss the solutions. So the first one, A, is y equals to ln of square root of with square root of x squared, x plus 1. So solution. Now, we have y equals to ln of root x plus 1. So this is the same as ln of x plus 1 base power a half. So what we do, we let this same thing can be written as a half ln of x plus 1. These are lots of logarithms. So we let u to be x plus 1, call it equation 1. So this means y will be a half ln of u, because this part is already u. Now, du dx will be 1, this from 1, and dy du will be a half. Now, when you differentiate ln of u, you get 1 over u. These are 1 over 2u, this from 2. So by definition, dy dx is dy du times du dx. So 1 over 2u times 1, which is 1 over 2u, and this will be 1 over 2 into x plus 1, or just say 1 over 2x plus 2. So that's the solution to that. Part B, y is equals to cos of x power 3. So we start by fixing this part. So we write let u be x power 3, call it equation 1. That means y will be cos of u, put here u now. So du dx is 3x squared, this from 1. And dy du, differentiate a cos, you get a negative sign from 2. Now, definition of dy dx is dy du times du dx, which will be minus sin u times 3x squared, and this you can write it as minus 3x squared sine of u. So therefore, dy dx is minus 3x squared sine of u, which is x power 3. And then C, function is y equals to square root of x power 4 plus 1. For solution, note that this can be written as x power 4 plus 1 raised to a half. So we let u to be the bracket, number inside the bracket, or the expression inside the bracket, call this one 1. And when you fix that, y will be u power a half for this one too. So from 1, du dx is 4x power 3. This from first equation. And then dy du is a half u raised to minus a half from second equation. So which tells us that from definition of dy dx, which is dy du times du dx, a half u raised to minus a half times 4x power 3. When you simplify this one, 2 and 4, 2 times will be 2x power 3 u raised to minus a half. So i.e. dy dx will be 2x power 3. I remember our u in this question is x power 4 plus 1 minus a half. You can write that one as dy dx equals to 2x power 3 over x power 4 plus 1 raised to now positive a half, which is 2x power 3 divided by square root of x power 4 plus 1. So that's what we get in that given problem. Number 4, or D, so y is tan of x over x plus 1. Now here, we are going to fix capital U to be this bracket, x over x plus 1. And this means now we'll have y will be tan of capital U. So call this one 1, I'll call this one 2. Now from 1, du dx. Now remember this is you use quotient rule. So we let this one to be a small u, this one to be small v. There's u prime v minus v prime u over v squared. So u prime, differentiate this one, you get 1 times v is x plus 1 minus, differentiate v, you get 1 times u is x, and then x plus 1 squared. So simplify the capital U dx equals to x plus 1 minus x over x plus 1 squared, which you simplify to this and this cancels, positive 1 over x plus 1 squared. And then from 2, dy, the capital U, is simply sec squared of u, because when you differentiate a tan function, you get sec squared. Then dy dx is dy du times du dx, which will be dy du is sec squared capital U times 1 over x plus 1 squared, which is the same thing as saying sec squared capital U over x plus 1 squared. So therefore, dy dx will be x plus 1 squared, and then sec squared. Remember, capital U was x over x plus 1. So write x over x plus 1. Then the second last problem, y is x squared plus 7x plus 2 raised to minus a third. So you fix this to be u. So u x squared plus 7x plus 2. Call this one equation 1. So which means y will be u raised to minus a third. Call this one equation 2. So du dx will be 2x plus 7. This from 1. And dy du is negative a third, u raised to minus 4 over 3. So by definition, dy dx is dy du times du dx, which is dy du is negative a third, u raised to minus 4 over 3, and then 2x plus 7. So which is the same thing as saying negative a third into u is x squared plus 7x plus 2 u raised to minus 4 over 3 multiplied by 2x plus 7. And so this is dy dx. Now the last problem is given by y equals to square root of 1 plus square root of x squared plus 1. Now solution, y equals to square root of 1 plus square root of x squared plus 1. You write it as 1 plus x squared plus 1 raised to a half. So this is the same expression. Now we let small u to be x squared plus 1. Let capital U be 1 plus u power half. So which means y will be u capital U plus, so u raised to a half. So just a minute. So we'll continue to finish that one later.